Alex submitted the first of a few proposals that will come in this year as he builds this system, a Reach for the Top main console. This is a two-part project to construct a scoring and playing system for the trivia game Reach for the Top. The idea is to be able to use this system to play games hosted by RSGC and to replace the current buzzer system. This new system will be controlled by a Mega 2560 rather, and have a 3D printed / acrylic case, battery, and outlet power options. First part of the project is the main console. The main console will have the scoreboard for the individual players and teams on one side using 7-segment displays and their accompanying ICs. Second side will have a control panel to alter scores and game settings using a button, to select a potentiometer to scroll through options, and an LCD panel to display the options. This device will be used by the game master. There's more here involving RF, etc., but that's it for me. Okay, Alex?
All right, so yes, so this is going to be a game console for Reach for the Top. If you don't know what that is, it's essentially a trivia game, sort of in the style of Jeopardy, like buzz in as fast as you can, answer a question, and RSGC plays Reach for the Top against other schools in the area, and I've been on the team, Vitushin's been on the team, and I decided that, so the systems that we use, you can see a picture of it right here, the systems that we use, I don't feel like they work very well, so I decided I was going to create a new one. The reason this one doesn't work very well, it's really old, and I really don't know when it first came to RSGC, but all of these pieces over here are the player peripherals, essentially. This is the main console, which I'm trying to replicate here, and these are more player peripherals for another team. And how it works is, it doesn't count scores at all. It just, you press the button, buzzes, locks all the other buzzers out. So I tried to get that working on this, however, all I managed to do is get the scoreboard running. Partially because I made an error on the PCB file for the controller side of it, so what would be most of the components here. So for now, all I've done is added a new part to this device in the center. You can see the device right here. It's got 28 of these 7-segment display systems, 14 systems, 28 7-segment displays, shift registers, resistors, etc. They're all given their own data bus and latch bus, and as Liam pointed out, I think last week, they can all be clocked at the same time. So I fixed that error on my PCB by soldering 0 ohm resistors across the data bus pad here. And the reason I chose 0 ohm resistors is because the leads are thin enough so that I can fit multiple into each of these cavities, and I wouldn't have been able to do that with wires. It was actually really tough getting the wire in this system to the Arduino. So like over here, I don't know how well you can see it. I've got this green wire is my clock pulse right here for the shift registers. These yellow wires I believe are for the data bus, and these blue wires are for the latches. Red and black are for power and ground respectively. And I'm using, as I said in my proposal, I'm using a ATmega 2560 or Arduino Mega with a shield on top. So this shield, I originally expected that it was going to have connections within it, but it's actually a point-to-point board. So I've had to do some new soldering techniques to get the point-to-point board connections, and that was a little bit tricky, but it's actually a lot easier than I expected. When I ordered this board, it also came with a a very small breadboard, which I'm currently using on the back of, I'm currently using it on the back of this PCB to get power and ground to the system, as you might be able to see. This white thing over here. Other details about this. So I ordered most of this stuff online, which means I wasn't able to, I probably should have tested the quality before I soldered everything onto here, because like this one isn't working. I've tried switching out shift registers, nothing changed. And then here I just made a soldering error. I soldered in a 47 ohm resistor instead of a 470 ohm resistor. Oh, sorry. And so, well, here's another image. Here's the image of the PCB file. This took me about maybe 2.5 weeks to complete. At first I didn't trust the auto router to get all of these connections correct because there's just so many, but there was no way I was going to be able to get all the connections on my own power with this. So this is the schematic from Eagle. It's hard to see, I'm sorry about that, for the Reach for the Top scoreboard system. This was the other PCB file I made. As I've said, I made a mistake on it, so I don't have it to present right now. The mistake I made is that I connected two of these buttons right here. I connected them to the same pull up or pull down resistor. I can't quite remember which one, but that kind of killed my project there for that PCB. So, but I'm gonna try and get this repaired for the next part of the ISP and have it ready for March, as well as the other peripherals. So I've got my work cut out for me for a little while. And in terms of code, what I did is I initialized all of the pins up here, and then also gave the 7-segment displays arrays. As you can see, there are two 7-segment display arrays. That's because for these two scores, these two total score pieces, the outputs of the shift register are on the least significant 7 bits, and for these are on the most significant 7 bits. So one of these is for just these two systems up here, and I think this one is for the remaining 12 over here. All it is just shifted down one. So, and then here, this is my function for putting values onto these displays. So latch low, shift out again, and latch high. How I managed to break down the values. So the scores, I was told to use strings. I decided not to do that. Instead, I just collected the value divided by 10 because it always rounds down, and then the remainder of that value divided by 10, collect them separately. And then I have to shift in the 1's digit first and the 10's digit second for whatever reason, based on how I managed to configure this. I also included Boolean statements here to ensure that I was shifting out the correct array piece, because I wanted to be able to use this function and not have to create multiple ones for the other array over here. So yeah, that's essentially how the scoreboard works for now. It's going to go under developments hopefully over the break and into the new year. Any questions?
Yeah, why some of the shift registers arranged in a different data order than others?
I think that was probably an error on my end. I didn't intend for that to happen. I just noticed it as soon as I plugged this in. While I was testing this, I was only really testing the score pieces for individual players.
Yep.
So I didn't notice this until I think the start of this week. Yeah.
So you said the yellow were data lines, right?
Yes.
So they're 8-bit shift registers. I'm just
Yeah.
kind of confused as to what it looks like. There's a lot more than 8 data lines, or is that 8?
It's 14. So there's 14 of these systems. Each data line corresponds to one system. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14.
Oh, right.
They shipped out in 8 bits. And That's also the reason I have these divided into two pieces, because I can't shift out 16-bit values. So I have to shift out one 8-bit value at a time to correspond with each digit. Yeah.
So you, at this point, any shortcomings of this board you're going to repair. You're not going to create a new display board.
I'm not going to create a new display board for this. This took.
So you can make that work for your main console.
Yeah. So I've got to figure out how to remove this display, the one that's not working, and I feel like removing this resistor and replacing it with the correct one is going to be too hard.
Is there any way? You said it was a 47K instead of a 470?
No, it was a 47 plain. It's
versus a
470. So all of these are powered. All of these are resisted by 470 ohm resistors. This one is resisted by 47.
A single resistor?
A single resistor.
Can't you get it out?
Huh?
Couldn't you replace it?
I could, but again, I only tested every single segment at the start of this week, so I also noticed this on, I think, Monday as well.
Yeah. I think you could probably get that out.
Any other questions?
How many, what's like the steps moving forward? Like, are you planning on relying on the Mega, or where does this go from here?
So I chose the Mega because it's got the most pins for me to use. I'm not too familiar with other Arduino models that have either the same number or more pins, so I wanted to play it safe. I'm gonna keep using the Mega for the remaining steps.
So I meant versus embedding and moving away from the Mega to a fully custom PCB, with the chip on it and that sort of stuff. Or?
I don't know, because the Mega's the microcontroller for this system is probably just gonna sit inside a 3D printed case, which is also something that I suggested I was gonna do in my proposal. I didn't manage to do that because I just couldn't figure out in time how to make a case for something this gigantic.
Yeah.
So I'm probably just gonna keep the full Arduino in there.
Okay.
I think we talked about creating an acrylic case for that, right?
Yeah, I got no idea how to do that right now.
I think we can't 3D print a case here, right?
We can print it in parts, so we can print half of the case.
I think a really nice acrylic case where you just basically design it in Adobe Illustrator or something like that, and then we get it cut.
Okay.
And we can get it cut, and you can put really interesting joints in there. I think basing it might be a little mini project on the side.
Okay. Well, I've got plenty of time over the break to look at that.
Yeah, and I'm quite happy to fund any acrylic purchases like this. I think this is a really great thing to showcase encasement of something on a much larger scale.
Okay.
Yeah.
How do you plan on interfacing with the buttons?
With the buttons, radio frequencies. So the NRF24L01, which I plan to use as the radio frequency module, can handle, I believe, 6 transmissions from a master perspective. So I'm going to use 2 of the radio frequency modules on this, and then I think 1 for each individual peripheral. I don't know if I'm going to manage to produce 12 by the time that we're presenting our next ISPs, but I'll see if I can produce 1 for each of you and Mr. Darcy. Maybe.
So the thoughts moving towards from wireless standpoint, using wires.
Sorry?
You want it to be wireless?
Yes, I want it to be wireless. Because the other disadvantage with this is that the players have to sit very close together. The distance between these peripherals, I believe, is a little less than a meter, so there's not a lot of space between the players.
Okay.
I want the players who are playing Reach for the Top to be able to sit all around the room. So with the wireless interface, you could be sitting in the back of the room and still be able to play a fair game with everyone else.
Okay.